All right. Okay, so what we're talking about today is we'll be talking about balanced equations. Everybody's familiar with balanced equations? We've done these before. Uh, So for example, we're gonna have the reactants on the left-hand side and the products on the right-hand side, okay? So in this case, we have the very famous equation of oxygen reactant or hydrogen reactant oxygen to produce water. Now, what we don't want to do is we don't want to change the subscripts to balance the equation. We only will change the subscripts such that we get a neutral species. That makes sense? So we have something that's electrically neutral on the product side. Does that make sense? That's the only time you ever play with the subscripts. So if we were to balance this, we see we have two hydrogens and two hydrogens. Here we have two oxygens and only one oxygen. Does that make sense? There's a couple ways we can balance this. If you're really good with fractions and you enjoy fractions, you could simply just throw a 1/2 in there and it'd be amazing. And that you'd be able to do that. Does that make sense? But you don't have to. There's a couple ways you can do this. Another way. What we could do then is since we had two oxygens here, we would put a 2 out in front of the water. That would then give us the two oxygens. However, that now gives us now the 4 hydrogens. So to balance out the 4 hydrogens, we would want to put a 2 out in front of the hydrogens. So now we have 4 hydrogens. That makes sense? Any questions on that? So here we have ammonium sulfate and barium chloride is going to produce ammonium chloride and barium sulfate. So we have ammonium sulfate with barium chloride. That's going to react to give us the ammonium chloride and then the barium sulfate, right? Now I'll talk about this a little bit later, but you should be able to see that here you have a cation, here you have an anion, here you have a cation, and here you have an anion. And all that happens in a chemical reaction is that this cation will now react with that anion, and this cation will now react with that anion. Makes sense? I'm leaving something important out, this intentionally, but we'll get to it. This will actually form a precipitate. So we'll see if we were to do this reaction, and we won't because the disposal of barium is so expensive now. It's a heavy metal, but boy, you can do some really neat reactions with it. If we were to do this reaction, we'd see a beautiful white crystalline substance at the bottom only. Barium sulfate. So, and what we see here now is we have two ammoniums with one sulfate. Now, why do we see two ammoniums? I know it's too early. This is cruel and unusual punishment. I shouldn't ask questions before 8. I get it.
Sulfate has -2 charge.
Exactly, precisely. So this has a -2 charge. So we need 2 of the ammoniums for that. However, over here, we only see one ammonium. There's only one ammonium. Why is there only one ammonium? If there's 2 over here, why is there only one right now?
Because with the chloride.
Because of the chloride. Because the chloride is going to have a -1 charge, and the ammonium has a +1 charge. Does that make sense?
Mhm.
You got to know those charges, right? You got to know those charges. Yeah.
So when building this equation on the product side, they just kind of like switch stuff around.
Yes. That's exactly what they do. So if you get reactants, we'll talk about this. We'll do this, right? So if you have ammonium sulfate, and if that's going to react with barium chloride, what all that happens is this ammonium will react with the chloride, and then the barium will react with the sulfate. The ammonium is not going to react with the barium because they're both cations. they're gonna repel one another. And the sulfate is not gonna react with the chloride because they're both anions and they're gonna repel themselves as well too. And so what you end up getting is you now get the ammonium chloride plus the barium sulfate. Does that make sense? Yeah.
Could be a silly question, but cations can never react with cations, right? They'll
They're,
repel.
exactly, because they're gonna repel one another. They aren't even gonna get near one another. So actually what happens is kind of cool. When you put all these things in solution, all these ions are actually solvated by water molecules. We'll talk about that a lot because I absolutely love that. But they will not go near one another at all. They will not because of the charges. They will repel one another if they're like charged. If they're oppositely charged, particularly here and they form a precipitate, they react with one another and they drop into solution. And it turns out that this is all based on energetics. So energetically, this is lower in energy when they are combined than when they are apart. And that's we'll talk about that as well too. But yes, two positives and two negatives will not come near each other because of electrostatics. Good question, good question. So I would look at this and say, well, this is +1, -1. So that's electrically neutral. This is +2, -2. This is electrically neutral. However, over here, I see what I have is I have two ammoniums. Here I only have one ammonium. So I would have to put once I have this electrically neutral, I want to work with just the coefficients out in front. Does that make sense? So now that I have two ammonium, I have two ammoniums, I have two chlorides. Now I have the two chlorides and then the one barium, one sulfate, one sulfate. Does that make sense? I do that every time. I've done this for longer than I care to remember. I write out the reactants. I'm going to recognize what are my cations, what are my anions. I'm going to switch them up, get them to be electrically neutral. All right, get them to be electrically neutral. Then I'll work with the coefficients out in front. Does that make sense? It's hard to believe, but I used to play a lot of basketball. It's way too much. I should have studied more, but I played way too much basketball. That's why I ended up going to Iowa instead of some other good school. I've shot a free throw for over 40 years. I still do the exact same thing every time. So when I do problems like this, I always do the exact same thing every time. It never changes. I got myself into a pattern, into a rhythm in which I identify the cations, I identify the anions, and I literally just switch them in my mind just like that every time. I try to come up with them to be electrically neutral, and then I balance with the coefficients every time. That's what I do every time. Every time. And it just tends to work out pretty well. And those of you in athletics, you'll find out that in this class, just like in physics, when you take physics, it just becomes muscle memory is really what it becomes. It's all really becomes. So far, so good. Does that make sense? So first thing I want to do is want to balance this equation. Let's see if we can do this. I'll let you all work. So I've actually made this electrically neutral. Why don't you go ahead and see if you can balance it, and I'll get it written up here. Bless you. Must be allergic to 745 class. I know I am. You balanced? All right. What's this compound called?
Nitro.
Oh, I'm gonna mark it wrong. Mean, aren't I? I should feel bad for my poor children. Close, not quite 3, it's copper 2. What's the charge of the nitrate? -1, right? This is gonna have a charge of -1. Right, that's gonna have a charge of -1. So if I have 2 of them, then this has to be copper 2 nitrate. That would be the charge of the copper. What's this stuff called? Speak up. Potassium hydroxide. This is a base, right? So anytime you see this OH, this will be a base, okay? All right. What's this stuff called? Copper 2 hydroxide. Does that make sense? Good. Yes. Yeah. I know. It's not even. It's barely 8 o'clock. I'm sorry. It's why we do this at 7:45. I have no idea. Even 8, man. Just an extra 15 minutes. Yeah. You know what? Let's just make it 9 o'clock. I think classes should go. Honestly, I really think classes go from 9 to 2, and that's about it. I concur. That would be if I could. I always tell my kids this, I said, boy, if they could just get rid of silly study halls and all the classes they really don't need, just go from 9 to 2. All good. All right. Yes, so this is copper 2 hydroxide. This is a base. We're going to do a lot with bases, okay? And this would be potassium nitrate, exactly. That makes sense? So how did you all balance this?
A 2 on the, yeah, that one.
Potassium hydroxide and then
And
a
then
Two there.
potassium nitrate. There we go. Nice, nice, nice. All right, we good? I'm gonna keep asking lots of questions because my goal is I like you folks. I really do like this class. Dr. Baldwin says good things about this class, but I don't want to see you in Chem 1 ever again. Yeah.
Why do you understand? The testing.
So I have 1 copper and 1 copper, right? I have how many nitrates? 2. I have 2 nitrates. And I have how many over here? 1. Right? Because this is all one thing. Right? You got to memorize those polyatomics. So I've only got 1 of them. So here I have 2, that's what the 2 indicates, right? So I have 2 of these nitrates. Here I've only got 1. So I have to put 2 in front of there. So now I have 2. I can't put a 2 here because this is -1 +1. I can't do that. Once I have everything neutral, I gotta leave it. I'm done with the little subscripts. NO3 always stays together in this class. Well, if we go further in chemistry, you find out I'm lying to you. But in this case, it stays together. So now I have 2 nitrates and the 2 nitrates here. Here, I have 2 potassiums, and then I'll put the 2 in front of there, but I've only got 1. So I have to put a 2 out in front of there. I can't put a 2 here because this is a +1 and a -1. So they're happy neutral. So now I've got the 2 hydroxides, and I happen to have 2 hydroxides. So once you get everything electrically neutral, once I get everything to 0, 0, then I start working with the coefficient. And the OH stays with the OH. It's not gonna break apart. Not right now. We'll deal with that later. This we're gonna just keep together, okay? Now, does that make sense?
Yeah, so. Are you gonna mark it wrong if I do like add the parentheses, like?
No. No, no, I, not at all. No, All right, let me do this one. This is boric acid. Put that in this. All right, so I'll write this down. It's 3, isn't it? It's plus. Got it?
Mhm.
Okay, I'm patient. At least I keep telling myself that. Have you ever listened to a pastor named Paul Washer? Very interesting. Actually, he got famous by preaching to college age kids. Incredibly godly man. But he would say that God will never give you a spouse that you're compatible with to teach you patience. And I go, man, gave me the greatest spouse in the world. We get along amazing. And I go, I got incredible patience. So then I project out, he'll never give me children, that would be compatible with me because I'll need patience that with it. Then I got my daughter. He said, Kate, amazing. So I have my daughter. Now I have the most patience of anybody. And then God gave me a son. I needed patience. I've learned them. I was telling my son I don't have any more patience. Walmart ran out. I have no patience. Did you get it? You ready? All right. So this would be what's this compound called? Boron.
All right.
3.
All right.
Trichloride, right? So this would be boron trichloride, correct? So boron trichloride. This stuff. This is boric acid. Don't worry about that. You don't expect to know that. And this would be
Hydrochloric acid.
hydrochloric acid, hydrogen chloride, either anyone. Yep. All right. One boron, two chlorides, one chloride. So we need to put 3 here, right?
Yeah.
And then we now have 3 hydrogens. 3 hydrogens. So we have how many hydrogens? 6. So I think we need to put a 3 there. And then now we've got 3 oxygens, 3 oxygens, everything's happy. Make sense?
Yeah.
See that? All right. We will not be able to do that items. This is what's this called? Calcium. That's kind of funny. Calcium silicate. Write this down. So,
Right, these chemical equations are we expected to write like solid gas and liquid or?
eventually you will, but not on this. You went,
Oh,
this you would not have any. You would never do this reaction. I would never do this reaction because of that stuff. There's only two compounds that scare me. One is cyanide, but I've worked a lot with cyanide, so it doesn't bother me. This does scare me. When I used to work at 3M up in Minneapolis, St. Paul area, the chemist. And they would use HF a lot to fluorinate hydrocarbons to make Scotch Guard and that sort of stuff. And there was a story of a young woman who was a chemical engineering major from the University of Minnesota, as a volleyball player. And she was walking by and a pipe of this broke, nailed her leg, burned her leg, but then this gas actually went through and started dissolving the calcium in her femur. Because calcium fluoride is soluble in water, so it will dissolve part of the bone. Yeah, pretty disgusting stuff. So, I had to go through all kinds of goofy training, even though I never worked with stuff, but I had to go through all kinds of training on this stuff. I don't ever want to play with that stuff. But that's in the gassy state. Once it's in the liquid state, when it's an acid, it's not so bad, but. All right, one calcium, one silicon, three oxygens, one oxygen, so we have to put a three right here, which really makes everything sort of nice now. We now have six hydrogens, so we need to put a six out in front of that. So that gets us to six hydrogen. Now we have six fluorines, and we have 4 and 2, which is 6, so everything should be balanced right now. And I know, and it's not even 8:15 yet. I know, it's just too stinking early. I'm looking forward to tomorrow sleeping. All right. And this one, I don't know what I was doing there. I have no idea what I was thinking. All right. Oh, when gallium metal is heated in oxygen gas, it melts and forms solid gallium-3 oxide. So let's write this out. Okay. So the symbol for gallium is going to be Ga. Gallium is an amazing metal. It's a metal that when you hold it in your hand, it actually melts. Yeah. We had some at one point in time, but it has since walked away. Somehow it melted into having legs and walked away somewhere. So gallium is going to be Ga, right? So it's going to be a gallium. That reacts with oxygen. How do I write oxygen? O2, exactly, precisely. Nice, nice. Now, this is going to form gallium-3 oxide. Okay. So if I'm going to write gallium-3 oxide, that means that the gallium has a charge of +3, right?
Mhm.
And then my oxygen is going to be a 2-, so I have to have 2 galliums and 3 oxygens. And if you wanted to, I don't care if you write charges up here, I don't care. Do what you gotta do other than cheating to get the answer right. Make sense? And anybody's gonna have better handwriting than me. Okay, now we gotta balance this silly thing. Well, I have 2 galliums, so let's put 2 here, right? I have 3 oxygens. Oh man, now I gotta deal with an even odd. Come on. Dang. Oh, right. Life is miserable. Well, why don't we let's just make everything even. How would that be? Should we make everything even? So if we're gonna make everything even, we're gonna put a 2 out in front of there. That gets us now 4 galliums and 6 oxygens. I can count. I know
Yeah.
it's hard to believe, being from Iowa and all, but I can do this. We did that. Let's say you like fractions. Let's say you're one of these goofy. Yes, I guess does this make sense up to this point? Anybody confused by this? Yeah,
I don't understand what the numbers.
okay, what numbers?
The coefficients.
Okay, so we're gonna start all over, this is good. Okay, so
Sorry.
I'm gonna start easy and I'll say, all right, I got 2 galliums, 1 gallium, so I'm gonna make this a 2 out in front of it. Does that make sense? But now I have 3 oxygens and only 2 oxygens. So how do I make 2 into 3?
Fraction.
I could use a fraction. I could multiply this by 3 halves. We'll do that in a little bit later. But I don't mind fraction. I know it's crazy. Well, you don't have to use them then. We'll make your life fractionless. All right. All right. We can do that. So I can't do that. So what I'm going to do is if I make this a 2 out in front of there. Now I've got how many oxygens? 6. Right? So I put a 3 out in front of there. Right? 3 times 2 is going to give me 6 oxygens. Now I have 4 galliums. You simply put a 4 out in front of there.
Why did it need to be 6?
If I just leave it as this,
Yeah.
That's probably good.
how am I gonna balance this? If we 2 galliums. Now I have 2 oxygens and I have 3 oxygens. How do I get them to be the same?
Yeah, you need 6.
Yeah, so I thought, well, if I don't want to do a fraction, I'll just make everything even. So if I make everything even, this becomes a 2 there. So now I have my 4 galliums, but now I have 6 oxygens. So I put a 3, you know.
Let me see, because there's no
4 there. But if I like fractions, let's say I'm one of these weird people that likes math. I could write, I know, they do exist, there's 3 in my family. We just don't love our daughter. My daughter doesn't like math, she doesn't love math, she didn't even like it. Oh, anyway. Yeah, well, everybody should. Hers is, she loves to hate it, that's her love and hate relationship. I love her dearly, she makes me laugh. She. So if I wanna do this, I could simply do this as 3 halves. And now that everything's balanced. But if you don't like fractions, it's these young ladies to the left and me, you don't have to, you can just make everything whole number. By making them even, and that's perfectly fine. I don't care. These are the same answer. So I don't care. I took a physical chemistry class. I took actually thermodynamics class in graduate school. And if I did not derive the equation the way the professor wanted to, if I did it a different way, I got it wrong, even if I did it right. And that always made me mad. So I don't, either one, I don't care. It doesn't matter to me. Yes, Zach.
So yeah, any of the elements like in the middle of the table are by themselves, they'll never have it, they won't have a charge.
Every element by itself. So the charge of this is 0. The charge of this is 0. The charge of all elements is always 0. Pick any element on the periodic table, the elemental charge of it in its elemental form will have 0 charge. It only has a charge when it's in its ionic state. So it either gives up an ion or it takes an ion. So in an element, if this is in its elemental state, it's by itself. This is in its elemental state, it's by itself. So the charge here is 0. So what happened is that the gallium gave up 3 electrons. This then gained those 3 electrons.
I have to ask, why is it 2 instead of this
Because we we have diatomics, right? So the diatomics are hydrogen, nitrogen,
Yeah.
oxygen, fluorine, bromine, iodine, sulfur's SH, phosphorus. That's fine. Not even 830. Yeah.
Even the sheet I can use for like the compounds like nitrate and. all that. So
I don't have a sheet. They're on the notes from last week. And then I can't remember what the table was. Sarah and I looked at the table. I can't remember what page that table was on. But you got to memorize those. Memorize the common ones, okay? You got to memorize the names, memorize the charge, and memorize the constitution, what puts them together. Yeah. Sarah and I were working on them yesterday. Did it help?
Yeah, a lot.
Yeah, and so once you start doing these problems, you flip back to that page, you get so tired of flipping back to the page, you just end up memorizing it. but it's the common ones, right? It's the hydroxide, the nitrates, the sulfates, the carbonates. The perchlorates, the hyperchlorates, we don't deal with those a whole lot, so I don't, I mean, the only one that you actually ever see is a ClO minus one, that's a hypochlorate, and that's what is found in bleach. That's it, but know those common ones, so, all right. Oh, liquid hexane, you have no idea what hexane is. We'll do hexane, all right? So now this. So if we take liquid hexane and burns in oxygen, this is going to produce carbon dioxide and water vapor, all right? So what is hexane? Okay, G6, yep, G6. 14.
14.
So it's an alkane, so it's an N, so it'd be the 2N plus 2. More fighting. So hexane, this hex means 6 carbons, and the ane means it's carbon-carbon single bond.
What?
I don't expect you to know that, I'm just explaining this to you. You'll learn this next year, those who take organic chemistry. What do you mean? You want what? You want to learn organic chemistry? You do? Oh, you don't want me teaching you. I all right. The only time I really didn't quite tell the truth in a job interview, I should record this, but I don't care. So I got my PhD and I could not get a job for anything. It was 2010. The job market was terrible. I got an interview at a school in North Central Kansas, and I was going to be the only chemistry person. They said, could you teach organic chemistry? And I didn't quite tell them the truth. And I said, yes, I could teach organic chemistry. Now, let's say that chemistry is this whiteboard, and let's say that organic chemistry is on that end. My PhD would be out in the hallway. It was so far away from organic chemistry, it wasn't even close. But I said, of course I could, because I needed insurance because somebody in my household wanted a baby. Babies aren't cheap. And so in order to have a baby, you got to get insurance. And so in order to get insurance, you got to have a job. So I said, of course I can teach organic chemistry. Oh, what in the world did I just do? But God in his divine providence, I taught myself organic chemistry one summer. Right after our daughter was born, I would go to bed at 4 o'clock in the morning, not because I wanted to, but that's the only time I could get sleep because she was a very needy little baby. So I would go to bed at 4 in the morning. I'd get up at 10 in the morning, and I would get myself down to the lab and taught myself organic chemistry. Yeah, I did sleep much. But anyway, hexane means it's 6. So for organic molecules, the meth is 1 carbon. F is 2 carbons. Prop is 3 carbons. Bute is 4 carbons.
And
Pent is 5. Hex is 6 carbons. Hepta is 7 carbons. Octa is 8 carbons. Nun is 9 carbons. Dec is 10 carbons. Undec is 11 carbons. Dodec is 12 carbons. On and on and on. If you have an ene back here, that simply means single bond. Ene is a carbon-carbon double bond, and ine is a carbon-carbon triple bond. There are 100 million organic compounds in the world. So the naming of organic compounds can be kind of tedious, right? I am not going to expect you to know this. I will not give you any test questions on this, but this is some organic chemistry, okay? That's the real basics. That course I took that college I taught that organic chemistry. There's a book in there on naming organic compounds. It was 250 pages, and I didn't read any of it. So you have 6 carbons, and so for the number of hydrogens that go onto the carbon, it's 2n plus 2. So if I have 6, that means it's gonna be 14 hydrogens. This is 1, 2, 3, 4, 5, 6, 1, 2. The rest of these are gonna be hydrogens because carbon always has 4 bonds. If you count the hydrogens, there's 6 and 6, that's 12, and 2 more is gonna be 14. So that's what it looks like. Or we could write a C6H14, which probably looks a lot better. When you take organic chemistry, this will be, you'll write this molecule this way. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's how you'll write the molecule. So each one of these angles represents a carbon, and you leave the hydrogens off. So that's how you would write that molecule. And you know what? It actually becomes quite simple. It really does. Once you, I will harp on this till you'll get the HS majors. You'll really dislike me a lot, because I'll tell those people who are going to be taking organic chemistry, I'll prepare you for organic chemistry, because it was my least favorite of all the chemistries I ever studied. But I'll tell you how to think about it, and it will make it a lot easier. And then I'll tell you the book that I used to help me to understand. And I think had I had a little bit more maturity when I was a student, I think I would have probably been a physical organic chemist. Because it turns out I really actually like this stuff. And once I learned how to think about it, I really enjoyed it a lot. I mean, a lot. It's kind of spooky because I used to hate this stuff. I really enjoy it now. All right. So anytime you take a hydrocarbon, so this is referred to as a hydrocarbon. Because it's got both hydrogen and carbon. And anytime you take a hydrocarbon and react with oxygen, what do you end up getting? CO2 and water. Any of you ever heard of a carbohydrate? Yeah. I'd be a lot more shapely if I didn't eat so many carbohydrates. But the wife makes amazing bread, so it's just too good. From metabolism, what is the byproduct? You exhale carbon dioxide and you can sweat water. Does that make sense? So this is basically like metabolism. You ready to balance this? I'll let you balance. I'll let you try it for a little bit. Always try something.
I
All right, or never, even if you don't know what to do, scribble something down. Always put something down. All right, we're all gonna have a problem. So we see 6. We're gonna put a 6 out front here, right? Right there. We got 14. We gotta put a 7. Oh crud. No. Right? But now we got something odd, right? So why don't we do what? I guess we could. Yes, you can. You can do that. Yep. we're gonna say, oh, crud, we don't like this. So we're gonna make everything even. So we put 2 there, it gives us 12 there, and now 14 there. Now we're kind of cooking with fire. Now we got 20. We got 22, 24 here, right? And 14, sorry, so it'd be 38. So that'd be what, 19?
Yeah.
We put 19 there. Think you want to put 19 halves there. Is what it makes. Good, does that make sense? All right. So 24 and 14. We're good? All right. I want you to write the reactants for this. So this would be when nitrogen dioxide is bubbled into water, a solution of nitric acid forms and gaseous nitrogen monoxide is released. So the reactants could be nitrogen dioxide and water are going to be your reactants, correct? Right, so that's the reactants. You have nitrogen dioxide and water are going to be your reactants. Nitrogen dioxide and water is your reactant. You remember what nitric acid is? That's one of those acids we want to remember. HNO3, yep, that's HNO3.
Yeah.
And then nitrogen monoxide is released. Ready to try this?
Yeah.
All right, I know I'm gonna mess up the first time, that's all right. All right, I'm gonna kind of start with the hydrogen, because that's sort of simple, right? Because when I look at this, I have a nitrogen here, but then I have 2 nitrogens there, so that seems kind of confusing. So I'm first gonna start with possibly 2 here. Everybody try that? We'll put a 2 there, that gives me, wait, not, oh my goodness. Sorry, not awake yet, sorry, gotta put a 2 there, there we go, sorry. Now we got 2 hydrogens, 2 nitrogens, 3 nitrogens. So if I put a 3 here, that work? So now what I have is I have 6, and I have 7, I have 6, and I have 7. Make sense?
Yes.
So my thought was here, here's what my thought was, I have nitrogen here, nitrogen here, but that seems kind of confusing. I got oxygen and everything, so I want to leave the oxygens alone, I don't want to mess with the oxygens. but I noticed that the hydrogen would be the easiest to balance. Does that make sense? The reason I started with the hydrogen was hydrogen only in two compounds. So I'm gonna start with the easiest. I always gonna start with the easiest and hope that the complicated ones just. So the most complicated of all this is gonna be the oxygen, because the oxygen is in all four of the compounds. So I'm gonna start with the simplest. I'm gonna start with the hydrogen. So I started with the hydrogen, saying, oh, there's two here, so I put a two there. And that got me 2 and 3. So I put 3 out there. Does that make sense? Okay. Okay. Now this will be what your lab is going to be on next week, all right? This has to deal with aqueous solutions. And once again, we're gonna have some more stuff to memorize. And it will be that the more you use this table, the faster you'll memorize. Okay? So an aqueous solution. So an aqueous solution is gonna be a solution in which a substance is dissolved into water. All right? Bless you. Water is going to be the universal solvent, meaning everything is soluble in water to some extent, to some itty bitty little extent. Some things are really soluble in water, for example, sodium chloride, sugar. A lot of these are going to be soluble in water. And what happens is in water, when it gets dissolved into water, it's going to dissociate into its cations or its anion. All right. Now, in this case, we have sodium chloride is added to water, all right, and all we're simply showing is that the sodium and the chloride break apart once it's in water. This is acetic acid. We'll talk a lot about this next semester. We won't spend too much time this semester. What happens is that this will break apart into its acetate as well as into its proton, and it will then dissociate a little bit. Now, does water conduct electricity? Not at all. Water actually does not conduct electricity. What happens is if there's any ions in water, that is what conducts the electricity. So the aqueous solutions conduct electricity because there are ions in there. Okay, there are ions in there. Pure water will not conduct electricity. It is going to be an insulator because it's what's called polar covalently bonded. And you're going to see this picture a lot. I would describe it a lot. What we have here is this is going to represent a granule of sodium chloride, where the purple spheres are going to be the sodium, the green spheres are going to be the chloride. So the purple is the sodium, the green is the chloride. These are going to be water molecules. The red sphere is going to represent the oxygen. The two white spheres are going to represent the hydrogen. And what happens is that the ions actually get solvated by the water molecules. So the water molecules surround the cation as well as the anion. All right. And so this is what happens when a solvent is ionic or is soluble in water based on ions. There's two ways in which things can dissolve into water. One is ions, all right, where you have something positive and something negative, and then the water molecule surrounds them. The next way something is soluble is going to be going in molecularly, and this is going to be methanol. Methanol is CH3OH. It's a carbon, hydrogen, 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 OH. And this, we call this a base in inorganic chemistry. In organic chemistry, this is an alcohol, right? If you ever go to the grocery store or you ever go to a hardware store and you buy denatured alcohol, they denature it by putting methanol in there. The reason, you know why they do that? Taxes, money, because some people can consume ethanol, beer, whiskey, wine, that kind of stuff. That's ethanol. But they denature it in that they add a toxin, which would be methanol to it, so you don't have to pay what's called a liquor tax or a sin tax, or whatever state they call it. And so they denature it because if you drink methanol, the first thing that happens is that you go blind. If you consume too much, then the methanol actually gets oxidated to become formaldehyde, which is what they use to preserve dead creatures. And so they denature the alcohol. Now, this is soluble in water, as we see here. However, it doesn't form any ions. So in this case, this will conduct electricity. This will not conduct electricity because it goes in molecularly. Any of you cook, like sweets, you like to make I don't know, add the sugar dissolve in the water? Yes, it does. It goes in quite well, but it does not go in as it does not go in as an ion. Instead, it goes in as a molecule. So when you put sugar into water, it will not conduct electricity. If you were to put salt in the water, which is what we see over here, it will conduct electricity because it goes in as an ion. Now this, like I said, this goes into water. It does not conduct electricity because it remains as a molecule. It does not break apart into its ions. Makes sense? Yeah, anytime you buy denatured alcohol, it will have this methanol in there as well too. And every chemistry department I've ever known of, and I think that's the same with this one, every chemistry department I've ever worked in has a liquor license. A license to buy alcohol. And the reason being is there are some cases in which you want to buy ethanol, which is what people consume, that is not denatured. That does not have this, because I can't remember the name of the reaction, but there's a reaction in organic chemistry where you want to use ethanol that does not have any methanol in it whatsoever. So every chemistry department I've ever been a part of, and I think this is the same one too, has some type of liquor license so they can buy that and not have to pay the taxes on it. So, but for the most part, this methanol will react the exact same as ethanol, except in that one reaction. Does this make sense? We'll end with this. So we have certain. An interesting thing about science is every time you learn a new science as if you're learning a foreign language, right? They have a ton of terms. I will never ask you to define a term on an exam. This is not a vocabulary class, but I will go over these terms for you so that we're able to communicate. Does that make sense? So you know what these words mean. Any of you ever heard of electrolytes? Yeah, you heard of it from what crazy drink? Gatorade. You know where that was formed, don't you? Know where that was made?
University of
You
Florida.
know the history of that?
University of Florida.
University of
Florida.
Florida. And why was that?
Gators.
They gave it, but why would they develop it there? Turns out they had really good football players, but about the third quarter, they were sucking eggs. They just could not compete, and people were destroying them in football. This would have been in the mid-60s. You know who actually made the Gatorade? Chemists. They went to the University of Florida chemistry department and said, could you make something for us? And so what they did is they put in electrolytes, which are things that are going to dissolve. I don't drink Gatorade at all because I'm not going to support that terrible university because I cannot stand the football program because I'm a Nebraska Cornhusker fan. And if you go, did I hear? Oh, really? We're gonna hopefully be above 500 this year, right? This is the goal. But if you go to the early 90s when we were in the 80s when we destroyed Florida, which made my little heart well and joy and happiness, and I loved it. I loved it. Danny Werfel, little pretty boy, would crush him. I loved it. Amazing. Mr. Heisman. Anyways, I don't like Texas either. Don't like Notre Dame. It's been for hours for teams I don't like. But electrolytes are going to be, so anyway, that's where it was developed. And it turns out that I believe in 68 and 69, Florida won 2 national championships with the worst quarterback in all history, Steve Spurrier, who happened to be one of the worst coaches of all time. I hate that guy too. And then we won it in 71, 72. But anyway, those are going to be electrolytes. And we also have the strong electrolytes. These are going to be electrolytes that exist almost entirely with ions in solution. We can have weak electrolytes. We are going to spend about a month in Chem 2 talking about weak electrolytes, and that's when we discuss equilibrium. And then you can have non-electrolytes. We talked about this where you have a sugar such as this would be glucose or methanol or ethanol, which is going to go into solution, but it's going to go in as a molecule. But they will not conduct electricity. All right. All right. What we're going to talk about on Monday is going to be precipitation reactant. This will be nice because this will pertain to the lab that you are going to do on Tuesday and Thursday. Does that make sense? And so what you're going to do is you're going to become very familiar with the solubility rules. Okay? So if you're bored this weekend and you have nothing better to do, you can sit and memorize solubility rules. Yes. Well, hopefully we'll watch Florida Gators lose. All right. Hasta la vista. Mirapavshim. Auf Wiedersehen. Ciao. Arrivederci.